I'm Anil Kumar, and in this video we'll explore the pattern of the given sequence. Consider the sequence 5, 10, 20, 40 and so on. Identify the type of sequence, write recursive formula, write general term formula, and write discrete function. Now whenever you need to describe the pattern, it is always important to compare the successive terms. In fact, we should see how the second term is generated from the first and how is third related with the second. So we have to analyze the successive terms. In this particular sequence, we see that the sequence is 5, 10, 20, 40. So there is doubling going on, right? So we can say that each successive term you can get by multiplying the previous term by 2, right? So, and we see this pattern is being followed. So, knowing the pattern, in this case it is times 2 the previous term, and since the ratio 10/5 of successive terms is 2, right? 20/10 is constant. So what we notice here is that you can get successive terms by multiplying each previous term by a constant number. That is to say that the ratio of successive terms is constant. In that case, we know it is a geometric sequence, right? So we can identify this one as a geometric sequence. Since each term is a multiple, right? So that is why we say it is a geometric sequence, since there is a constant ratio. I have introduced equal ratio, constant equal ratio between consecutive, or I could say successive terms. Now, knowing this, we can actually find different kinds of formulas for a given sequence. One of the formulas is called recursive formula. In recursive formula, we are trying to relate every term with the previous term. So recursive formula is relation So in this case, how are they related? So we can say that term Tn is equals to 2 times the previous term. So we can write this as 2 times Tn minus 1. So n minus 1 represents the previous term. So that is how we can relate it. So in successive formula, to know any term, we should actually know the previous term. Then only we can find the next term. So there is another way of relating the terms in the sequence, and that is general formula. Now in general formula, we can find the term by knowing the term number. So this is related with term number. So in this case, let us say the first term is 5, second is 10. So like this, we know T1 is 5, T2 is 10, T3 is 20, and so on. Now we need to give a formula so that we can directly get the number as in relation with its term number, right? That is what the formula is all about. So we can say Tn is equal to 5 times 2 to the power of n minus 1, correct? So let me write it in bracket like this. So when you see, we can write this as 5 into 2 to the power of n minus 1. Now if n is 1, in that case it will be 2 to the power of 1 minus 1, 2 to the power of 0, which is 1. So it will be 5 times 1, which will give us the first term. If n is 2, then exponent n will be 2. So we'll have 5 times 2 to the power of 2 minus 1, which is 5 times 2, 10. You get the idea, right? So that is how we can find it. You can write these multiples as in relation with first term and its product, right? So here you multiply the second term by 2 to the power of 1 and get the second term. And then if you want the third term, then you have to multiply by 2 to the power of 2. That is 5 times 4 is 20. Do you see that? So this power is 1 less than the term number, and that is why we have this formula, right? So that is how you can write general term formula for a given sequence. Now there is another term which we use, and that is discrete function. So all these could also be written in the function form, that is f of n is equals to 5 times 2 to the power of n minus 1, right? So that is also a function form which can be utilized, and we call this as a discrete function, since here n belongs to set of natural numbers. So that makes it discrete, right? Now whenever we say n belongs to set of natural numbers, we know that n is 1, 2, 3, 4, correct? Now in case of a recursive formula, I need to modify this, rather add very important aspect which I forgot. Whenever you are defining recursive formula, in that you have to define the starting term. So we have to write here that starting term is t1, which is equal to 2, right? And in this case n is greater than 1. So we can find all the n's which are greater than 1. N equals to 1 is already given to us. So that is how we should write the recursive formula. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.